So hi, folks. Welcome to our session. It's really wonderful to be here in London with all of you. I'm Prajakta. I'm one of the product leads for cloud networking, and I drive a variety of products in my portfolio. Really excited to be here.
Yeah, and thanks so much for maybe wrapping up your day here with us. My name is Mike Columbus. I am on a network specialist team that helps our cloud customers with all things networking.
So what we're going to talk about today is Service Mesh. Now, some of you may be familiar with Service Mesh. Some of you may not be familiar with Service Mesh. At a very high abstract level, a good way to think of Service Mesh is that it takes what an application does. So maybe that's the application logic, that's the business logic, and then it takes that and it separates that away from the application networking. So who is a Service Mesh for? Let's say you've got a large deployment of microservices, and you have applications that need to be multi-cluster, multi-region, sometimes multi-cloud as well. You have multiple languages in use, so these could be because of your developers, they just code in different languages. The other thing is that your environment itself is heterogeneous. So you could have VMs, you could have containers, or you could have a mix of both, plus things like bare metal in your environment. You also want an easier way to ensure that you can control how your apps communicate with each other. So for example, you want to segment your applications, or you want to ensure that when application A talks to application B, they are secure in terms of the way they are communicating. And then a lot of you roll out code almost every day. So you want modern traffic management. This would be things like canaries, blue-green deployments, advanced things such as mirroring, circuit breaking, and so on. But you don't want to have the toil of actually going and configuring all of these. And you want to do all of this as easily, as uniformly as possible, and with enough visibility into what's going on with your services. So this is a slide from Tim Hawkin, who's one of our leads for Kubernetes. He presented this at KubeCon just a few days ago. And what does a service mesh really give you? So it gives you a bunch of things, or it should give you a bunch of things. One is that it virtualizes the service, which means the service has a name, the service has an IP, which also means you need a way to go discover these services. It also gives you client-side load balancing. Now, for those of you who are load balancing developers or have used load balancers from 6, 7 years ago, all the load balancing used to be server-side, which means your client hits the server, and the server decides where the traffic should go. Here, it's the client. In the service mesh, the client decides which instance of your service to go to. And that is what is client-side load balancing. Then you want traffic management. This could be things like traffic splitting, but it could be also advanced traffic control facilities. And then you want endpoint management, because you don't want your services to go health check each other to see which ones are healthy. The other thing is, we often talk about access control, we talk about identity, and we talk about encryption and zero trust. So what's the difference? Access control is who can send and receive. Identity is who is sending and receiving. And encryption and zero trust is, if I got something, why do I believe it? So that is what your service mesh provides. Now, let's go create a service mesh. So let's say each of you had, let's say, a VM-based monolith. Now, it's got a bunch of code, or a lot of your modules, but it's also got a bunch of networking code. Let's take the code, let's chop it up into microservices. That's what you see on the screen. What you do now is, where do we put the networking code that used to exist in your monolith? What we do is we take all of the networking code, and we encapsulate that into what we call the service proxy. Now, this service proxy is going to do everything networking, which means your application and your business logic does not need to have any networking code. And this type of a model is called a sidecar, because as you can see, it's sitting just next to your application. Now, if you come to, essentially, what did we just do? We created a data plane which had services, and it had proxies. The moment you have a proxy, a very popular one is Envoy proxy, which originally came from Lyft and is open source, you have a programmable data plane. But that does not mean it becomes a service fabric. You need some intelligence in the control plane to take all of these discrete elements and build a service fabric. And so that's why you have the service mesh control plane, and that's what brings all of this together into a service fabric. So now we created the mesh. We have our services. We have our sidecar sitting. We have the service mesh control plane that is controlling all of these. But this is what's called inside the mesh. You need to guard the entry point to your mesh, because maybe you want to defend it against DDoS attacks, or you want to put some WAF rules, or you want to put the same traffic management and routing capabilities like canaries and traffic splitting for your edge. And so that is what you see, which is called the ingress. You'll hear terms like ingress, ingress gateway, and several other terms, edge proxy. That's another term you might hear. So we put that. Now let's take a closer look at the service mesh control plane. A well-defined service mesh control plane should be modular, and the typical modules you will see are related to traffic and configuration and security. So what happens with the traffic module? It is also generally a configuration module, which means if you configure a traffic policy or if you configure a security policy, it's this control plane that goes and plumbs it into the proxies that are sitting inside your data plane. So if you think of it, we spoke of the mechanics of what your service mesh enables. But what it really enables you to do is it enables you to manage the flow of traffic coming inside, within your mesh, and going out of the mesh. What it also lets you do is it gives you full control on the security aspects of service A communicating with service B, and for all of the services in your mesh. And then the third thing, which is very important, is it gives you full visibility into what's going on in your mesh. And this is at the service level, not at the infrastructure level, not at the container level, not at your hardware or virtual network, at the service level. And it gives you deep insights into what's happening and what kind of policies you should be putting in there to ensure that the behavior of your services is as you want it or as you expect to be. So, actually, there is a very interesting nuance which I wanted to point out, which is, if you notice what we did, we separated the application from application networking. The moment you do that, as a developer, what you need to do is code your app, and then there's an ops person who's going to go worry about the policy, or your security admin. So you actually decoupled the development from operations. And what you also did is you provided a consistent way, because if you notice, the service mesh is not tied to any particular type of compute. It works for VMs, it works for containers, it works for bare metal, it could work for something else that comes along. And so the key property of any managed service mesh is that it should support all of these, because without that, you cannot really manage a heterogeneous environment. So what are the three popular service mesh options we see in Google Cloud? The first one is open source Istio. How many of you here are familiar with open source Istio? Okay, that's a big chunk of people. Then there is actually two offerings from Google Cloud, which are managed by Google. One of them is Traffic Director, and the other one is Anthos Service Mesh. And we'll talk about these in the next few slides and so on. So what happens with open source Istio? Essentially, if you now take what we described about the service mesh, so in your data plane, you have your services. Then you've got a sidecar proxy like Envoy, which sits next to them. The control plane for the traffic part and configuration part has an open source component called Pilot. And then next to it is an entity called Citadel. This is the one which actually does all of the certs management. So a good way to think of it is as a certificate authority. Because when you want to do mutual TLS, you will need all of these certificates, tokens, to be propagated to your data plane, so your services in the data plane can communicate with each other securely. All of this is great, but what else do we need? To bring Istio to enterprises, when we started talking to our customers, they said, some of the things they said, first of all, we don't want to manage the service mesh control plane. That's not our core competency. So we wanted to go deliver a fully managed control plane. The second thing they said is, we love the openness of it, because the APIs between the control plane and the data plane are open. They are called XDS v2 APIs when you use the Envoy proxy. And then we said, let's preserve that openness, and let's also offer in services and support with an SLA on top. And then the last thing is, a lot of our customers want multi-cluster, multi-region services. You do have to stitch a lot of this yourself. So you'll have to put in ingress gateways and stitch the whole solution together. And so that's when we decided to look at managed options. Now, the first thing we wanted to also tackle is observability. So how do you get deep visibility into your mesh? And that's when we thought, let's create a service graph that gives you this deep visibility. And so that's where the Anthos Service Mesh started. It is now in beta. It has basically open source Istio Pilot. It has a managed certificate authority, and then it's got a service graph. So this is what the service graph looks like. It gives you a neat and nice graph of all of your services. And it's almost like a topology graph, if you will, just that it's of services. And it gives you characteristics of your services. So this is where we started building out a managed offering. And the focus was initially on building this topology graph and then giving you visibility. Then we said, OK, what about the rest of the pieces? Where is the managed control plane? Where are all of the advanced capabilities? And there's a series of things at Google which we have capabilities that don't exist elsewhere. How do we go offer it to the Service Mesh customers? And so that is where we started with Traffic Director. Now, if you think of Traffic Director, think of all of the things we spoke about. One is that you want GCP to go manage, or Google Cloud to go manage your Service Mesh control plane. So that is the first thing we did. Then what we did is we bundled enterprise-grade SLA and support on top of that. And then the last thing is what a lot of customers love Traffic Director for, which is we wanted them to have global load balancing for internal microservices and to do multi-region, multi-cluster container and VM services. And in fact, Matt Klein, who's the creator of Envoy Proxy, he's been involved in this project from early days, and he's been a huge source of support and also in terms of the feature set that we should build. So the thing that differentiates Traffic Director from other service mesh solutions is this notion of a global service mesh. So it's not just open, it's not just managed, it's also global. And what does that really mean? So first of all, what it means is that it's a mesh. If you notice, I didn't say VMs or containers. It provides a global service mesh for VMs, for containers, whether it's Kubernetes, a self-managed Docker, or GKE, which is our managed Kubernetes. And then, many of you here run internet-facing workloads, and you use our global load balancer, where you put your backend instances wherever you want. We give you a single Anycast IP, and we let you, it'll do cross-region failovers, overflows, and so on. Imagine bringing all of that to microservices which are internal-facing. And so to give you a closer look at what this global load balancing with Traffic Director and what a global service mesh looks like, I'd like to invite Mike.
Thanks, Prajakta. All right, so to really understand Traffic Director, and before I show it to you, I do have a demo set up that we can look at. I think it's super important as a techie to understand the data model, right? How is this configured to really drive home how it looks on Google Cloud Platform? So the first thing that's configured when you configure Traffic Director is a global forwarding rule, right? Think of this as identifying your service. So this consists of a port, an IP, and a protocol. The other thing you can do is if you want to just purely do L7 host or path-based rules, you can also have an all zeros default forwarding rule that will catch everything. So when you redirect things to your sidecar proxy, you can purely just do L7 routing rules. So once we have our global forwarding rule defined, we then have a target HTTP proxy. Think of this as a logical config pointer that logically consists of all the Envoy sidecar proxies or whatever sidecar proxy you're using in the service mesh. So really, it's just basically identifying where all these services will be programmed. This consists of a URL map, which is tied to your HTTP proxy, where you can define rule matches and then actions you'll take on that. So the URL map points to a back-end service. This consists of where you'll configure your health checks, things like affinity settings, circuit breaking, or outlier detections that you can configure within your service mesh. Backend services then point to either managed instance groups or network endpoint groups. These can be globally deployed, right? So the backend service can reference network endpoint groups in any one of our regions, which is really just a port and IP pair, a way to natively target containers on our platform, or managed instance groups, VMs as such. Okay, so here is a quick example of our environment that I have set up today called Cloud Shop. This consists of a front end or a web service, which is running Docker containers on VMs. And then we have our cart service. This is running in managed instance groups. And then finally, we have our payment service. This is running in GKE, and the backends consist of network endpoint groups. The other thing we need to consider is within the mesh, the forwarding rules apply, right? So that's how you identify a service and associate specific routing policy for that service. but we need to get onto the mesh. So for this environment, we're using our global load balancer, which again has backends deployed in US Central and Asia. And this essentially routes clients to the closest, healthiest backend with available serving capacity. So Maya in California would route to the US Central environment, provided there was serving capacity. Similarly, Shen in Singapore would route to the, or route, I should correct myself, to the web service in Asia Southeast 1 if it was available. From there, the sidecar proxies within the mesh would target the closest, healthiest available backends. So web to cart, cart to payment, throughout the mesh as a service chain. So again, we see the affinity based on location. So this is global routing out of the box, right? So you don't really have to do anything to have this localized service selection take place. This is because Google knows where all its endpoints live, knows where all its zones live, and can take TTL snapshots as part of a config map to know exactly how to weight traffic throughout your service mesh, which is really powerful. So in this slide, what we see here is our cart service in US Central 1 failed. So I'm going to show this, but what happens with Traffic Director is the cart service in the web service in US Central knows that service failed because we're providing managed health checks and can seamlessly point that next hop to available serving capacity in Asia with no involvement. Should that service come back up, service is healthy again. So if we can switch to the demo, we're going to buy some things. All right, so the first thing I want to do is just talk a little bit about the environment that is built. So we have, I'm going to switch to a different project here. So this is a live environment, and I'll talk through the different components of it. The first thing is the web service. So we can see we have managed instance groups of 1. I wanted to be somewhat frugal, but of course these things could be auto-scaled. But we have 1 managed instance group in Asia, 1 in Central. Similarly, we have our cart service, again, in Asia and Central. And then we have our payment cluster, which is a GKE cluster of 1 node. And then if I jump over to our Kubernetes environment, we can see we have a payment service running in both Asia, on the Asia cluster, and 1 on the US Central cluster. From a load balancing perspective, here we can see, and I'm not going to go too deep into this, you can see that we have a global load balancer deployed. This consists of 1 backend service, with the backends being in Asia and US Central. And then if we jump to Traffic Director, we can see we have identified our cart service, which consists of the VMs globally. And then we also have our payment service, which consists of the network endpoint groups that were deployed in the Kubernetes service. There's an annotation on the YAML. I didn't want to show YAML today for some reason, but that actually will spin up a controller which keeps track of all the network endpoint groups or our endpoint pods. So we have our environment configured. What we'll then do is let's jump to our website and buy some things, right? So this domain is live. It's actually using a Google managed cert on our global load balancer. The one thing I did, because I can't have you all stopping services, is I put it behind an identity-aware proxy, so you need to have a Google LDAP to get through. But I'll open it up later if folks want to play around with this. So here, what we can see is that we fit the web service. Being in Europe, we got routed to the closest, healthiest backend, which was US Central 1. And then, we can buy some sunglasses, add them to the cart. See the cart service is US Central 1. And then when we confirm the purchase, we can see this was served by the payment service. But again, what would happen if we stop the cart service? So what I'll do is I'll stop the cart service here. And then what will happen is if we go into Traffic Director, eventually we'll see that the service will become unhealthy because the health checks will fail for that service. So there you go, right? So one of the cart services is down. Let's buy something else, right? So let's go back into our front end, and let's make this a little interactive. Does anyone have a preference for what we buy? Shout it out. Radio. Okay. I'm going to get the vintage Bluetooth radio. So we can see this is served by the web service, but when we add this to the cart service, you'll notice that because, well, I'll talk a little bit more about what happened, but the web service knew that the sidecar proxy knew that there was no available serving capacity in the closest zone, so it failed over across the world to Asia. And then, again, because now we're an Asia cart service, this is going to pick the payment service with the healthiest available serving capacity, which again is local. So what we'll do, you notice we don't have any delivery charge here, so that's a teaser for a future demo, but let's start the cart service back up and we'll switch back to the slides. I want to talk a little bit about what happened there. Okay. So the first thing is, how does Traffic Director, how do these Envoy proxies know where these endpoints live, right? So for managed instance groups, we have what's called back-end manager, which is keeping track of, is this VM healthy, is this endpoint healthy and available? And that talks to Traffic Director. So Traffic Director can then go and then inform all those Envoy sidecar proxies, hey, you have serving capacity here, this is healthy, here's how to get to it. For containers, which are using network endpoint groups, it's fairly similar. When you have a neg annotation on your services, there's a controller that gets spun up that talks to Traffic Director and similarly tells the Envoy proxies where things live and if they're healthy. So when we failed the cart service in Central, what happened? We're health checking these endpoints as a service. That's talking to Traffic Director. Shopping cart failed in Central. I'm sorry, cart service failed in Central, and we removed that to all the proxies within the mesh, saying, hey, you can't get here, right? But from a data plane, what happened? And I think this is really interesting. So try to follow as best as you can. And we're going to take a view of this from, we came in through the global load balancer, hit the web service up at the top there that's running and has Envoy installed as a sidecar proxy. So we're going to have the view of the web service. So the service itself resolves the cart service, right? So web wants to talk to the cart. It has a VIP that's globally significant, but it doesn't have to be a VIP from your VPC. This could really be any address. So what happens is the web service tries to talk to the cart service, resolves the cart service, and sends traffic to it. On this VM, we have NetFilter configured that basically redirects as part of the output chain to the Envoy sidecar proxy. The proxy then intercepts the request, applies the policy that was configured, and then sends the traffic on the way. But you'll notice here, that sidecar proxy knew the cart service was unavailable in Central. It actually sends that traffic directly to the endpoint with the client. The web service has no idea where the traffic's actually getting into, like where it's being sent. So with that, I'll hand it back over to Prajakta to talk about advanced traffic control.
Thank you, Mike. So I'm going to deep dive into some of the advanced traffic control. We probably won't have enough time to go through every feature. I just wanted to say there are about 134 features, but we'll give you a highlight. And then before I do that, I'm excited to announce this is in GA today. And I wanted to give a shout out to our engineering teams who are in Boston, so Cambridge, and in Sunnyvale. So wherever they are, thank you for shipping this feature out. So what can you do with this? Basically, if you think of what you're doing with the DevOps stuff, where you want to change the flow of traffic, but you want to do it in a policy-driven way. That is essentially what you're getting with these routing and traffic policies. So think that the policies are essentially in two types of buckets. One is routing rules, and the other is traffic policies. Now, routing rules are things like traffic splitting, traffic steering, timeouts and retries, fault injection. So just things that let you go and ship out your code very easily. And then the other side is traffic policies. So how do you want to go load balance your traffic? Things like outlier detection and circuit breaking, and then we'll talk a little bit about that. So let's first look at what are the kinds of things you can do with Traffic Director. This is the data model. Mike showed you the data model earlier. What you can see here is under the URL map, you can see a bunch of routing rules. So these are the things that you want to match your traffic on, and then you can take actions. And the actions could be things like go rewrite my URL, or go redirect from HTTP to HTTPS, or go and split my traffic. It could be more than one of these. Mirror my traffic, inject a fault, so I can do testing and so on and so forth. But as you can see, everything is plugged into this data data model, and you will notice that as we talk about more and more products, you will see that the data model is very uniform across different products. So we'll talk about that. So the most popular feature that I get asked for is traffic splitting. This is where you've got traffic, you've got two versions of the service. So you want to say send 99% to one and 1% to another. So that's a very popular ask. You can do that easily with Traffic Director. It's purely a policy. Then you can do traffic steering. So this would be things like if user agent is foo, go here. If user agent is bar, go to the other service. So you can, everywhere you can see that in the diagram is the service A that's deciding which one to go to. But the plumbing of this is actually coming from Traffic Director into service A. And that's how service A says that I need, if it's, let's say in this case, the user agent is Android, I go to service B1. And if it is iPhone, I go to service B2. Another one is fault injection. So this is if you want to see what would happen to your service if there was a fault. Like let's say there's an abort or there's a delay. You can simulate all of these conditions by actually going and putting these metrics and then having it play out as you go test your code. Mirroring is my personal favorite. So what you can do is you go create a shadow mirror service, and then any traffic that is coming to a service will be mirrored to the shadow service. This is extremely helpful if you want to go and test, let's say, your service, which is not yet shipped on production code. So you're not touching your production service. You're simply mirroring the traffic to this shadow service. The second thing that you can do is imagine there's some sort of an issue in production. You can just mirror the traffic to another shadow service and debug the problem there. And there are several other use cases for this mirroring as well, including audits and so on and so forth. The second half of it is traffic policies. So if you think of how we do Traffic Director and what we spoke about, first there's a global policy, which is let me go select the optimal region for the traffic that's coming in. So let's assume you're from US Central in that case, and then if you're from California, you'd land up at the instances or the region in US Central. Once you've done that, then you specify the policy, and using that, the instance just figures out how to actually go and pick one of those instances, the destination instances, things like round robin, least request, ring hash, and so on and so forth. And then you can also layer in things like affinity. So if you want to stick your traffic to a particular instance, you can do that as well. Can be done based on cookies, can be done based on IPs, and so on. This is the most interesting one, which most people are not familiar with, which is circuit breakers and outlier detection. And here, imagine that a service is saying, I can accept, let's say, X max connections and so many requests. And if you send me more, here is what you should be doing to yourself. That's basically what circuit breaking is. The difference from typical implementation is that the enforcement of this policy is here service A and not service B. So service B is specifying how it wants to be talked to. And service A, the proxy on service A, to be more specific, is enforcing that policy. So this prevents your services from getting overloaded, especially when you have a chain of services. So it's, again, a very popular feature. Most people don't use it enough, but it can be very handy. So with that, I wanted to invite Mike to give a demo of traffic splitting.
All right, thank you. So we are going to switch back to the demo laptop. Thank you. All right, so we're going to buy some more things here. So what I want to do is introduce a new service to the environment. We're going to call this the payment delivery service. So when a user wants to check out, we're going to calculate a delivery cost. It's not real, but it shows up, so it's good to demo. So let me reconnect here. So what we're going to do is we're going to deploy the service. We're going to add the back-end service. We're going to add the back-ends to that service. And then we're going to configure traffic splitting to send half of the traffic to that goes to the payment service that will calculate the delivery. The other half will not. So I have this scripted here, and I want to talk through what I'm doing. So the first thing we'll do is let's get credentials for our Kubernetes cluster, which should already work. So I went right to the deployment. So what this is doing is I'm deploying two files in both Asia and US Central on those Kubernetes clusters. That's going to be our delivery service. Okay. So we see that was created in Asia, and we're going to create that to payment cluster in US Central. The next thing we'll do, let me run this, and then we'll talk about what we did. This is going to, so when we make the deployment, we added the shipping deployment. to Kubernetes. One of the things, let's see if I can get this to show up here, was that when those pods were created, they had a network endpoint group controller annotation on them. So what we're doing here is we're creating the delivery backend service. Again, when we do traffic splitting through the URL map, it targets or it splits across backend services. So that is kind of like the path. So what we're going to do is create the delivery service. We're going to health check it. And then we're going to add the 2 network endpoint groups, the one in Central and the one in Asia, to that backend service. And that's what we just did, right? So I ran that shell script. In the final step, we're actually going to do the splitting. So let me run this, and I'll talk about how this works. So we're going to basically take the current URL map, which is sending everything to the payment service, and we're going to say, hey, send half to our new delivery service. So I can show you what this looks like. Basically, we have a match rule, which is everything, and then we're basically doing weighted back-end services. So 50 to the payment service, the other 50 to the delivery service. And again, those are global back-end services, so we're going to have all that goodness of the global routing. So everything ran. Let's jump back over into Traffic Director and take a look and make sure everything's healthy. So we can see that we now have 3 services. One is partially healthy, so this does take a minute to actually, for everything to come up. But we can see our delivery service was populated. So if we just want to drill into the delivery service while this is spinning up, you can see we have our 2 network endpoint groups for the delivery service, and we're health checking that service. And then from a URL map perspective, let's jump into the payment map. We can take a look here, and we can see, again, this might be a little small, but here's our URL map that's splitting 50-50. We could also annotate on here, hey, also mirror this traffic. There's all sorts of things you can do here. But we'll keep it pretty simple for now. So let's jump back and just make sure everything's healthy here. All right, so everything's healthy. So now we're going to buy more things, and I'm going to need help from the audience on figuring out what to buy. So again, we're going through the same website, and the only difference now is that we have traffic splitting on the payment service. So what are we going to buy? Anything jump out? Teapot? All right. It's an expensive teapot. So we'll add the teapot to our cart service. Again, that's served by the cart service in US Central 1. We'll confirm the purchase. And I think because things were failing over, but you can see, now we can see that the delivery was actually calculated. So if we refresh this a few times, you can see that, you know, the delivery service went away. Delivery cost went away. Let's refresh this a few more times. Should be roughly half, but sometimes you get a little bit unlucky. All right, I'll try a couple more times. It's like a flip of a coin. There we go. So we have the payment, or the delivery cost calculated, which was, again, that other deployment in Kubernetes. And again, you know, we didn't put in any data here. It's just a demo, so that's what we show. So very good. So if we can switch back to the slides. Thanks.
Can we switch back to the slides? Okay. Okay, great. So we're going to give you now a sneak peek at a bunch of services that also exist along, features that exist along with this. We probably won't have enough time to deep dive, but we'll give you, and then we'll point you to our website where you've got more and more information about this feature. So one of the things that we spoke about was the authorization, authentication, and encryption. And that is what we speak about when we speak of service-to-service security. So again, if you look at the data model, you will notice that it's the backend service where you're doing a bunch of settings to go enable these policies. But these policies are specified, again, in the control plane and plumbed to the data plane by Traffic Director. So how do you actually do the cert management? Where are the tokens coming from? All of this is being done through a component. If you're playing with open source in Istio, you're using a component called Citadel, and that is what is actually providing the certs or CSRs to be more specific. Now, when you come to us and you say we want a managed control plane, you also want a managed CA. And that is why we recently had the beta of managed CA. And for any production workloads, we recommend that you use the managed version of it, and it'll take away the toil of lifecycle management. The other feature is observability. So there is actually multiple options for you. One is Envoy itself allows you to pull out signals, and you can pipe them into any favorite tool of your choice. So you can pipe them into Stackdriver. The second was the observability, the service graph that we showed you. That was the topology graph in Anthos Service Mesh. And then the last one is essentially what one of our partners did, which is using an open source product called Apache Skywalking. So this was put together for a customer by Tetrate, which is one of our partners. And then you can see it's a different form of service graph where they have information about services. And this is also a set of services. You can drill down into the services. So this is another open flavor of the service graph that you saw before. I wanted to call Mike to talk about a flavor that you may not have heard about, but let's have Mike describe it.
Thanks. All right, so we announced the L7 internal load balancer at Google Next in Tokyo around the summer timeframe. And this really fits two purposes, right? The first is probably the most common, which is I want an internal managed service from Google that provides L7 rules and routing rules, right? The ability to do things at L7. Google predecessor, or the other load balancer, was L3, L4 for internal. The other thing was, how do I want to bring all the features that Envoy and Istio bring to the table in Traffic Director without, if I can't install a sidecar proxy for Brownfield, right? How do I get there, right? And that's one of the key things that I'll actually show later that L7 ILB provides. So let's imagine, here's our environment again. We have our web service, and then we have a shopping cart service. But let's say the team that owns that service can't install Envoy's sidecar proxy for whatever reason, but wants the ability to actually split traffic across the payment services. It's legacy appliance, whatever, right? The owners of this team can't do that. So we can actually enable the advanced traffic management and advanced traffic control by inserting the L7 internal load balancer into this architecture as a middle edge proxy, right? So under the covers, how does this all work? When you deploy the L7 load balancer, the first thing you need to do is deploy a proxy address pool from within the VPC. A /24 is recommended, but we can go as small network range as a /26. What then happens is Google will run a pool, an elastic pool of Envoy proxies as a middle edge design. And this follows the same data structure as the other load balancers. This is abstracted from you. And what happens is, as the shopping cart wants to now send traffic to the payment service, we have this elastic pool of Envoy proxies that will manage on behalf of you as a managed service. And that traffic will then be seamlessly routed across, load balanced across these proxies. Your routing policy, or basically your configured policy, will apply to these proxies and then get sent to the payment service. And there's all sorts of functionality in this product, but it's a middle proxy design. And one of the things I want to show, just to reinforce the consistency across products, is the L7 ILB in that exact architecture I just showed. So if we could switch back to the demo. All right, so what I'm going to do is I'm going to jump to a different project. Now, I'm going to just do a quick walkthrough of what's in the project. So we have the same thing, right? We have the web service, we have the cart service, and then we have the payment service. Because the L7 ILB internal load balancer is regional, these are only deployed in US Central. But one other difference amongst this is that there's no sidecar proxy into the cart service. The cart service basically exists for others to target it, but there's an L7 internal load balance that the cart service is then going to use to send traffic to the payment service. So let's jump over to load balancing, and I can show you what this looks like. So again, we have our global load balancer that gets traffic to the web tier. But again, the difference is we have this payment internal load balancer with two regional backends. The reason being is that I already pre-configured the splitting across the delivery and the payment backend. And we can take a look at what this looks like. It looks the exact same as Traffic Director config, except we're targeting the two backends in US Central, which are regional backends. So I have another store. This is going to be the ILB demo. And I'll show you this working. So we'll buy a clock. We're going to add it to our cart, and we'll confirm the purchase. And what you'll notice is that we're splitting and traffic's flowing similar to the Traffic Director deployment, except this is going through envoys that are basically pulled out of the cart service, and Google manages as a horizontal pool of load balancers, sidecar proxies. So I think that's it. I'll hand it back to Prajakta to wrap us up.
Thank you, Mike.
Yep.
So I wanted to take some time, maybe I'll look this side. I wanted to take some time, and I wanted to just bring together everything that we spoke about, and I know it was a whirlwind tour. But if you really think of the different capabilities that we spoke about a GCP managed control plane. We spoke about the API that exists between the control plane and the data plane. And whatever service mesh product that you use, make sure that API between the control plane and the data plane is open, because if it is not, you're not going to be able to go and switch your control planes. And you're not even going to be able to switch from the open source versions of those to whatever the provided managed versions are. The third thing is, how did you configure? So right now with Traffic Director, we support configuration via GCP APIs, and we also support configuration via CRD. So we have a product called Config Connector, but and I'll tell you when the next set of API configurations are coming. I don't know if you realize this, but we spoke about service discovery, but we didn't show you an explicit service discovery anywhere. So it was hidden in a lot of the stuff we described. So when you put your endpoints inside a network endpoint group or a managed instance group, with the network endpoint group and with the other one, there is inbuilt service discovery. So you don't need to go and really go create a separate service discovery mechanism. When you actually when you configure the data model, the service discovery is built into that data model. So you automatically get that. Then the one which is a huge differentiation, which is multi-cluster if you're using containers, or even the global routing, where for any given service, you can actually go and put your instances anywhere you want across the globe, and then you saw the cross-region failover and overflow. So there is no other solution in the market that does it for internal microservices. So that would be one big reason to go give this a try. We spoke about managed CA, which interoperates with Traffic Director, so you can do mutual TLS between your services. We also spoke about the various ways you can do observability. So you can either just use the Envoy and use the programmability and observability it offers. You can also use open tools like Apache Skywalking. And then the other one is basically your control plane observability. So we didn't speak much about it, but you can also visualize and monitor how Traffic Director itself is working. We support VMs, we support containers, again, containers of all flavors, which is self-managed Docker, open source Kubernetes, and GKE, which is our Kubernetes, managed Kubernetes. We support all of the protocols like HTTP, all the modern protocols, HTTP, HTTPS, HTTP2, gRPC, and we will be enhancing these to support more, including things like TCP proxy. And then the last thing is, so what are the things that we plan to add that don't exist in here? First one is, which is why this diagram. So the things that you see in blue, in 2020, what you will see is that Traffic Director will get bundled in as, you can think of it as pilot in the land of Anthos Service Mesh, and it will be the traffic and configuration control plane. What will come from the Anthos Service Mesh side, one is config via Istio APIs and the Kubernetes style APIs, which will come from the Kubernetes land. The other thing will be, you saw that beautiful graph, the topology graph that was in Anthos Service Mesh. Mesh. We will have Traffic Director work with that as well. And then the last one is we have several customers who want the same capabilities for endpoints that are not just in GCP, but they're sitting in on-premises and other clouds, and we will also add support for that. So the reason we created this abstraction of network endpoint group is we want to be able to put all kinds of endpoints, and that is how we will support things that are not in GCP. So you'll specify an endpoint in there, whether it's an IP port pair, whether it's a domain name, and that is what will be that endpoint which doesn't sit right in Google Cloud. But actually, once you have, we spoke a lot about service mesh today. When you do service management in Google Cloud, you have a lot more tools at your disposal. So if you just care about load balancers, a way to think about load balancing is we have several load balancing flavors. We added 2 more constructs in there. One of them is the layer 7 internal load balancer. So you don't need to know it's Traffic Director and Envoy proxy because it looks like any middle proxy load balancer to you. But that is how we build it out under the hood. Traffic Director is basically a new way of doing load balancing for your microservices, where it brings in the client-side aspect to it. Because all of these other flavors really mostly are actually server-side load balancing. And then obviously all of our load balancing flavors work for the things shown here: Compute Engine, which is our managed compute VMs, Kubernetes Engine, storage, and so on. The other way to look at it is, let's say you care more about the multi-cloud modern services, and you're trying to go modernize your applications. And this is where you, again, have a slew of choices, but they're all brought together into a platform that we call Anthos. And you can think of Anthos as an opinionated stack, which lets you do Kubernetes orchestration, service mesh, serverless with Cloud Run, and then there's things like configuration, telemetry, and so on. So if you notice in here, there are several open source. For each managed piece that we have an entity in open source. So should you choose to go do your testing with the open source variant, you can. Generally, when you deploy production traffic, you'd prefer to have a managed version for 2 reasons. One is you could use your developers in a much better way than building out these control planes or managing them. And then secondly is you get services and support. So if something goes wrong, you have somebody to talk to. So protocols that are going to be extremely important in the world of microservices would be things like gRPC. You will see a lot of announcements from us coming on that end, possibly early next year, and especially things related to gRPC and service mesh. We believe it's going to play a very critical role in providing some of the capabilities that service meshes need. I would say one interesting thing to think about is we already spoke to you about 3 service mesh flavors, where you put an edge proxy, you put a sidecar proxy, and you put a middle proxy. And one of the things to keep in mind is that these products are going to keep evolving to solve your use cases. So if you need a different variant of service mesh, do ask us, do ask your service mesh provider, because we feel like the innovation has just started. There's a lot more that needs to be built. And then a few links that we have in here for you. But I would say the best way to get started with service mesh, if you haven't already started on it, is literally go fire up a Google Cloud project. You can see the UIs for traffic control. You can see the UIs for Traffic Director. Just go to our Pantheon UI, configure a simple service, maybe try to replicate some of the demos that Mike did, and he's going to open source many of these, like that shop that you saw. You can change the products if you didn't like these, but he's going to open source that as well. So we'd love for you to try it. Let us know what you'd like us to add in Traffic Director and for Service Mesh in general. And we hope you're able to take all of these tools and go modernize your services. So thank you for staying with us till the end of the session. Thank you.